This is the screencast for section 4.2, example 2. So you saw some examples of graphs that satisfy the mean value theorem. We're going to look at some that don't and why they don't. So explain why each of the following functions fails to satisfy the conditions of the mean value theorem on the interval -1 to 1. So in A, we've got the graph of the square root of x squared and then plus 1, so we move that up 1. Can you see why it does not satisfy the mean value theorem? That's right, f of x is not differentiable at x equals 0. There's a cusp here. How about B? There's a piecewise function. Can you see why this would not be satisfying the mean value theorem on the interval from -1 to 1? Yeah, there's a jump discontinuity here at x equals 1, so there is a discontinuity. And I know it's at the end of the interval, but it's still included. There is a discontinuity here at 1, so it does not satisfy the mean value theorem. The now try problem number 3 says state whether or not the function satisfies the hypothesis of the mean value theorem on the given interval, and then if it does, find each value of c in the interval a to b that satisfies the equation. Okay, so let's first state whether or not the function satisfies the hypothesis of the mean value theorem. Do you see any reason between -1 and 1 where f of x equals x to the 1/3 or the cube root of x would not satisfy the mean value theorem? Not so fast, not so fast. F prime, in this case, would be 1/3 x to the -2/3, which then would be 1/3 times the cube root of x squared. So what is the domain of the derivative here? That's right, it would be not including 0, because 0 would make the denominator of the derivative 0. So this function is not differentiable at 0. I didn't do a very good job of drawing it, but there is a vertical tangent here at 0. So the function f of x is not differentiable entirely between -1 and 1, so it doesn't satisfy the mean value theorem.